Very good morning to all of you. I am Dr. Kumari Sarita Prashad and I am Assistant Professor of Chemistry at RN College, Pandol, Madhubani. Today, I will be talking about a very important concept in organic chemistry. Have you ever wondered what happens when a carbon atom loses one of its bonding electrons? The result is a fascinating and highly reactive species called carbocation. In today's session, we will explore the nature of carbocation, how they are formed, their stability, their classification, their some important reactions. Now, in this topic, learning objectives are the first objectives are define and classify carbocation, understand carbocation and differentiate primary, secondary, tertiary, allylic, and benzylic types. And the second objectives is formation and stability analysis, describe formation mechanism and analyze factors like inductive effect, resonance, and hyperconjugation. Now, the next objective is real world application. Evaluate practical examples and identify reaction involving carbocation intermediates. Now, first of all, we will discuss about what is carbocation. A carbocation is a reactive organic ion with a positively charged carbon having only 6 valence electron. You can see this picture. Now, the characteristic of carbocation is also known as carbonium ions. They are crucial intermediates in organic reactions like substitution reaction and elimination reaction. The next, hybridization and geometry. What type of hybridization and geometry of this carbocation? So, the central carbon is sp2 hybridized, forming a trigonal planar shape with a vacant p orbital, which make it highly reactive. Key properties. Carbocation have a +1 charge, 6 valence electron and short-lived and act as a strong electrophile. Classification of carbocation. So mainly carbocation classify into 5 classes: primary, secondary, tertiary, allylic, and benzylic. So what is primary carbocation? So primary carbocation, it is only one alkyl group attached to the positively charged carbon, making it less stable. Now the secondary, 2 alkyl groups enhancing stability compared to primary carbocation, and the tertiary carbocation stabilized by 3 alkyl groups, offering the highest stability among simple carbocation. Now allylic, positive charge adjacent to a double bond allowing for resonance stabilization. Benzylic, positive charge adjacent to an aromatic ring benefiting from resonance stabilizing. So it is most stable carbocation, benzylic carbocation. Now, next, factor affecting carbocation stability. So many factors affect their stability. Inductive effect. Alkyl groups donate electron density to the positive carbon, stabilizing it. More alkyl groups mean more stability. Now the next stability factor is resonance stabilization. Delocalization of the positive charge through pi bond, example in allylic and benzylic carbocation, significantly increases stability. Now the third one is hyperconjugation. Interaction between the empty p orbital of the carbocation and adjacent CH sigma bond, providing electron density and stability. And last one is steric effect. While less direct, steric hindrance can something influence the geometry and indirectly the stability of carbocation. You can see this picture. Now carbocation stability examples. You can see this allylic resonance. Allyl carbocation are stable because their charge can spread across 3 carbon like this. Now next is benzylic factor. Benzylic carbocations are stable because their charge can spread into the ring of atom. Next, rearrangement. You can see this picture, rearrangement. I zoom it. Carbocation can shift paths like hydrogen or methyl groups to become more stable. Tertiary carbocation is more stable in comparison to secondary and primary. Now next, common reaction involving carbocations. So the common reactions are SN1, E1, Friedel-Crafts, hydration of alkenes. So first one is SN1 reaction, nucleophilic substitution, especially with tertiary alkyl halide, proceed through carbocation intermediates. E1 elimination reaction, unimolecular elimination, form alkenes via carbocation followed by beta hydrogen loss. And third one is Friedel-Crafts alkylation, carbocations from alkyl halides alkylate aromatic rings enhancing reactivity. Fourth one is hydration of alkenes, acid catalyzed water addition involve a carbocation intermediate favoring more substituted carbon. Now summary and question and answer. Recap of key takeaways and an opportunity for questions like definition. Positively charged carbon intermediates with trigonal planar geometry, reactions SN1, E1 and hydration reaction, stability influenced by alkyl substitution, resonance, hyperconjugation and steric factor. Now thank you all.